welcome to the discussion board team lead week 5, failure to comply. This week the problem was, let's suppose that you are the disease outbreak coordinator for the Center for Disease Control and Prevention. A recent flu outbreak has led to a successful recovery without long-term problems with a probability of 93%. Your team runs a test in a small town and determines that in 20 people, 19 successfully recovered. If you hypothesize that this small town has a higher recovery rate, will you be able to reject the null hypothesis, the alpha being 0.05 or 5%? What if 20 successfully recovered? Provide your alpha observed in both cases. What your figures in the above two questions reveal is a lack of statistical power. That is, with such a huge probability of success and small sample size, it is hard to fall below the set level of alpha, which we've already determined is 0.05 or 5%. One option proposed is to increase the sample size from 20 to something more applicable. What is the smallest sample size needed so that it would be possible to reject the null hypothesis? Out of this sample size, how many successes would it take to fall in the cutoff region, i.e. alpha observed is less than or equal to the alpha? So step 1, we identify the hypotheses. So H naught is that pi is equal to 0.93, 93%. And the alternative hypothesis is that pi is greater than 0.93 or 93%. Step 2 is we're going to identify our decision rule. So we will reject the null hypothesis if the alpha observed is less than or equal to 0.05 or 5%. If we do not observe this, then we will fail to reject the null hypothesis. So step 3, we're going to calculate the binomial distribution. So we're going to determine our alpha observed, looking for the probability that x is greater than or equal to 19, given that pi is equal to 0.93. Our alpha observed when x is 19 is approximately 0.3526. The alpha observed when x is 20 is approximately 0.2342. The alpha observed when x is greater than or equal to 19, which is to say 19 out of 20 occurs and 20 out of 20 occurs, we need to add those two values. So we get approximately 0.5869 or approximately 59%. So then we'll proceed with step 4, which is what naturally comes next. We're going to analyze the computation that we made in step 3. So our alpha observed for x being greater than or equal to 19 is approximately 0.5869 or about 59% with round. So given that, we will be unable to reject the H naught with our alpha being identified as 0.05 or 5%. The alpha we observed when x was greater than or equal to 19 was approximately 59%. So this is far greater than 5%, clearly. So we won't be able to reject the H naught. This error is likely due to the sampling variability that occurs when you take a relatively small sample compared to the large quantity of people that the consensus will typically capture. We're going to determine the smallest sample size required to project each knot. So like we said, the current sample size is 20. It's too small to feel comfortable in rejecting hypothesis. So we ask ourselves, what is the probability that X is greater than or equal to X, given that pi equals 0.93 is less than or greater to equal to the alpha given, which is 0.05. So here we set up a pretty simple mathematical equation indicating that 0.93 to the what power equals 0.05. So we can find out exactly what the sample size needs to be for it to equal the alpha. Then we can later determine through analysis what would be less than the alpha, right? So we go through the math of this, and we determine each side is a natural log. So we say the natural log of 0.93 to x equals the natural log of 0.05. And we know with logarithms, we could pull the x out at that point. So we have x times the natural log of 0.93 equals the natural log of 0.05. So we can divide both sides by the natural log of 0.93. When we do that, the natural log of 0.05 divided by the natural log of 0.93 is essentially just a value. It's x equals 41.28019393, which is approximately 41.28. Now, in analyzing that, in order for the alpha to be less than 0.05, we would need a sample size of at least 42 people. So now that we know the sample size that we would feel comfortable in rejecting the hypothesis, we need to understand how many of the new sample size would be less than the alpha. So this can be done through trial and error using the binomial PDF function in your calculator. So you would go to second bars and scroll down to A, which is binomial PDF. Input your new number of trials or sample size, which we identified as 42. We type in the percentage, which is the probability of success, which would be 0.93. And through trial and error, we would just go down the line. 41 out of 42 trials evaluates 40, 39, 38, 37. Until we get to 36, and we identify that that's actually less than the alpha of 0.05. It comes out to 0.045. I went one step further just to feel a little better about it, and did the binomial PDF with 35 successes. And it's definitely lower than the 0.045, so I felt really good about that. 36 as the number of successes of the 42 sample size as being the appropriate answer. So thank you very much for listening. I hope this helps, and have a great next week.